day one of coding projects until I graduate from a master's in data science or until I get a job post-grad. I'll have each day of progress uploaded to both my GitHub and my Kaggle so you can follow along to the code day by day. In order to do any project, really, there has to be a problem that is waiting to be solved. Therefore, today, on day one, we're going to identify it. Then, we're going to map out our problem, and then we can see what approaches that we can use to solve it. Recently, my music on Spotify has kind of dried up, and I've been looking for new music, and I've been trying to find what songs sound like each other. So, let me give you an example of what I mean. Here, we can listen to Pretty Young Thing by Michael Jackson, and it's being sampled by Kanye West in his song, Good Life. And now, if we listen to Good Life by Kanye West, we can hear a little bit of a mix-over.
Like we always do with this time, I go for mine, I get to shine, now throw your hands up in the sky.
Just at the start there. That was it. Songs that sound alike. And look, if I search up songs that sound like Good Life, we're not going to get anything but other songs that are called Good Life. Maybe I'm searching wrong. Maybe I don't know what I'm doing on Spotify, even though I've been using it for however long. But it's still a problem that I have. So, in order to solve this problem, there must be a basic structure to this project. First, we got to worry about data collection. We got to somehow download MP4s or MP3s of the files for all the songs, and we have to create a data set. Honestly, that might take a lot of space on my computer, so we'll see. 2, we have to extract our features. We got to figure out what it is in that data that we need in order to create a model and run the model based off of. 3, we must then process our data. So then we got to clean and normalize our data so that way we can work with it. 4, we got to select a model. And for selecting a model, I'm thinking of using a convolutional neural network or a k-nearest neighbor. Maybe even a support vector machine would work. But we'll have to look into that further once we get through our data and we start analyzing our data. 5th, we must then train our model. We have to split our data into a training and a test set. Therefore, our model doesn't know what it's looking for when it's being trained. 6, we then must evaluate our model. And since we're looking for a similarity, we may want to use a cosine similarity evaluation or a Euclidean distance evaluation. So overall on day one, we made sure to identify our problem, and then we got to map out our solution and how we're going to get to our final product. Thankfully, that was kind of the easy part. And everything else from here on out will be a tad bit more difficult, as I'm still new to coding and I'm still trying to figure it out. So that's where you guys come into play. If you guys have that's where you guys come into play. If you have any suggestions on how to make my code better or how to help me with my approach to this project, please comment down below, as I'm still in my first semester of the program and I'm eager to learn. Thanks for watching day one. And I said I'd be coding, and so here's your first piece of code. Hello world. That's pretty solid.